floor exponential equation here. Now I want to review just briefly an example of what we mean by the floor function, and I have some up there for you. But like, say if you have the floor of 1.6, okay, floor of 1.6, and these square brackets denote the greatest integer function, also called the floor function. This is equal to 1, since 1.6 is trapped between 1 and 2. Okay. Now again, I'm gonna go ahead and just dive into the problem here. I've tried to color code this thing. Notice up here that the right-hand side of the equation is equal to 1, and so these two laws of exponents are really what drive the solution to the problem. Okay. So we need to come down here and ensure that this condition occurs. Now that's equivalent, actually, if you just trust this, the example I just did, that's equivalent to just writing down 1 is less than or equal to 5x minus 7 5x minus 7 is strictly less than 2. Okay, but you can see this resolves fairly quickly. If you add 7 to both sides, right here and divide by 5, you'll get 8 over 5. Eight over 5 is less than or equal to x. You see, we're actually going to have a range of numbers that have a floor of 1, which is important here. Less than or equal to x, strictly less than 9 over 5. So that's going to be part of our solution set. That's all of the bases of 1. All of these values of x have a floor of 1, which would make it base 1, a base 1 in the exponential equation. Okay, so this is part of the solution. And we also have to ensure that the exponent, remember, this guy's behaving like the exponent. Anything raised to the 0 is equal to 1. So that's why we have to set this quadratic exponent. Now this factors nicely. X minus 2 times x minus 7 equals 0. Okay, and so we see that we can quickly see that the other two solutions would have to be x equals 2 and x equals 7. Okay, so these two single values, along with this range of values over here, is the solution to the equation. This is an interval of numbers, okay, and this is just two singletons. Now, just a kind of a little check here, if you didn't trust this, notice that 17 over 10, this would be what, 16 over 10, 18 over 10, and so 17 over 10 would be contained in this interval, okay? And this is just an example. X equals 17 over 10 would be in that interval. And notice that if you substitute 17 over 10 right here, I'll write it off to the side, you would get the floor of 5 times 17 over 10. Minus 7. Okay, and it's pretty easy to verify. It's pretty, that would be minus 7 right there. 5 times 17 over 10 minus 7 floor. Okay, and you can establish fairly quickly, if you take a look there, what that would have to be equal to, right? That's definitely equal to 1 if you do the arithmetic, because this would be what, 17 over 2 minus 7? 17 over 2 minus 7, okay, and that would have a floor of 1 if you want to carry out the calculations. Okay, folks, but again, this is the final solution, x equals 2 and 7, and then this interval of values right here is the solution to the equation. Hope you enjoyed it.